Welcome to the second part of our disease prediction system video. In the first part, we saw the demo of the project, and in this second part, we'll be seeing all about dataset that was used, algorithm that was used, accuracy of the system, and so on. So let's get started. So these are the technology and tools used. In the backend, the system have used Python programming language along with the libraries like NumPy, Pandas, and Sklearn. And to deploy the machine learning model, Python Django is used. For the front end, of course, HTML, CSS, and JavaScript are used along with jQuery and materialized CSS. So if you want heart disease prediction system in your machine, then make sure you've installed all of the backend tools, and you need to run few of the commands, which I'll just leave it in the description below. For every machine learning model, you need to follow certain steps, and heart disease prediction is no exception. There are a few of the steps that are involved in heart disease prediction systems. So we will see that and heart disease prediction system side by side as well. Now the very first step in developing any machine learning model is data collection. So basically quality and quantity of data determines how accurate the model will be. So it is very important for you to choose the correct and right amount of data. In this project of heart disease prediction system, we have used a dataset from UCI machine learning repository, which I'll also leave the link in the description below. So this is the dataset that is being used in this project. It has 13 different attributes and a target. So the target basically signifies if a patient has heart disease or not. 1 means the patient has heart disease and 0 means the patient does not have heart disease. So basically 13 different attributes that the user need to give is denoted as X, and the target value, which is 0 or 1, is denoted as Y. It starts with 2 and ends at 304, so that means it has 303 different instances. It's not huge dataset, but we're going to work with this anyway. Heartdisease.csv right here is our dataset that will be used in the project. If you want to know more about these 13 different attributes, then you have all the description right here in the screen. You can see that. Now after data collection, it is very important to clean the data, which involves the likes of removing the duplicate data, removing or modifying incomplete data, and so on. Basically, we need to prepare our data such that our model will give the correct output. Here in this project, data is already ready-made. It does not have any missing values or the repeated values. Originally, this dataset had 76 different attributes, which was converted into 13 attributes with the feature extraction. It was done by various machine learning engineers. So we haven't done any data cleaning or data pre-processing in this project of our disease prediction system. Now in the third, we need to split the dataset into training and testing data. As the name implies, training data is used to train the model, whereas testing data is used to test the model. In this project, dataset is split into 70% and 30% with the help of Sklearn train test split. Among these 303 instances, 202 is for the training, whereas 101 is for the testing. If you see here in views.py, then we have split a dataset into 70-30, which is 1/3. It is right here. So our X and Y, which we denoted for 13 different attributes and target, is splitted. Now in the fourth, we need to create a model itself. To create a model, you need to use machine learning algorithm. There are different machine learning algorithms available, such as SPM, linear regression, KNN, and so on. Depending upon the problem you are solving, the use of algorithm may differ. However, in this project, we have used logistic regression right from the scratch. So let's talk more about logistic regression, since it is the spine of the project. Logistic regression is basically supervised learning and classification algorithm. So the value of logistic regression must be between 0 and 1. Why is that? We'll just see in a second. But since it must be between 0 and 1, it forms something like S-curve, and the S-curve is called the SigmoidFunction, or basically logistic function. So we have a simple graph here for understanding the basics of logistic regression, which is of course from 0 to 1. Here we can see something like S-curve that we just talked earlier. And this 0.5 is a threshold value. Anything above threshold value is considered as 1, and anything below the threshold value is considered as 0. So here, since the prediction is 0.8, the person has heart disease, and here since the prediction is 0.3, the person does not have heart disease. So one of the most important thing that you need to know about logistic regression is it uses gradient descent to make our model more accurate. Gradient descent acts like an update function, so it is used to find the next step using the derivative and learning rate. Derivative is basically used to find the direction of the next step, whereas the learning rate is used to find the magnitude of the next step. That means how much further we need to go. So this update function is repeated until the convergence, or basically repeated until the number of iteration. So using this formula, we'll basically calculate where to go next. So I'll just show you the simple figure so that it will be easier to understand. Let's say this is the curve that our logistic regression is trying to follow, and we start from here. So what gradient descent basically does is it basically helps us to find the next step, which is here. So using the derivative, we know where direction to go next, and with the help of learning rate, we know how much to go next, or basically the magnitude of the next step. So it is very important for us to have a proper learning rate. If you have a small learning rate, then you'll get the good path of the curve, but it does not show you the bigger picture. It only goes in downward direction, but the curve is like this. So this is because of the very small learning rate. Also, if you have a very big learning rate, then it knows which direction to go, but since the learning rate is high, it will just jump back and forth just like this, and our logistic regression basically cannot follow the path of the curve. So in any machine learning project, you should not have a very huge learning rate or a very small learning rate. Here in the project of our disease prediction system, we have the learning rate of 0.0001 and the iteration of 1000. So basically we repeat this process to go to the next step for 1000 times, and where to go next is of course given by this. And also there is something called SigmoidFunction. So this formula basically ensures that the output lies between 0 and 1, hence the S-curve. Again, if the value is higher than threshold, it is considered as 1, and if the value is lower than threshold, then it is considered as 0. So here in regressor.py, we have implemented logistic regression right from the scratch. Here we input all of the necessary libraries, and here we have implemented logistic regression right from the scratch. So if you don't want to implement logistic regression from scratch, then you can also just import this logistic regression right from the library called scikit-learn from one command. But we have implemented logistic regression right from the scratch here. We have a class called logistic regression, which has three main functions. One is fit function, which is basically used for fitting the dataset into the model. And next we have update weight function, which is basically the helper function to update the weight in the gradient descent, which we just discussed this earlier. And we also have a predict function, which is basically used to predict the probability. And here we just imported dataset in here and splitted that into x and y, the 13 different attributes as x and the target value as y. So here are all the comments for you to better understand. So this code is given in the description below. You can go ahead and check that out. After creating the model, we basically train the model with the training dataset, which is of course 70% of the entire dataset. After this, our model will learn some kind of pattern, and it can basically predict on its own. After training the model, we can give the data to the model just like in part 1 and basically get the output in terms of probability. Our model is already made, but we can always evaluate and improve the model. You can use other different datasets, change the algorithms, pre-process the data and so on to basically improve the model, but we stick with this dataset and this algorithm. So let's see all about the accuracy of the system. So the accuracy is given by the number of correct prediction by total number of prediction made into 100%. Of course, we had 101 different instances on which the prediction was made. Number of correct prediction from 101 was 71. So we divide 71 by 101 into 100%, and the accuracy of the system is 71.287%, which is not that super impressive, but since we've implemented logistic regression from scratch and the dataset is fairly low, it is what it is. To calculate the stuffs like precision, recall, and f-score, we need to know what true positive, false positive, and false negative are. So true positive are those examples that were actually positive and were predicted as positive. So that value in this heart disease prediction system is 29. False positives are basically those examples that were actually negative, but our model predicted them as positive. So false positive in our model was 6, and the false negative are those examples that were actually positive but our model predicted them as negative. So that value is 23. Now here this is the calculation of precision, recall and F score. By the way, there was the feedback system as well. So if you want to incorporate your email in that feedback system, then you can just scroll down here in use.py and you see this code right here is used to send the email. So you can change the email right here. So it basically sends the mail to heart disease prediction system. So I guess this concludes the video. I hope you guys loved it. If you have any questions, then you can comment down below. So this is pretty much it. Thank you for watching. I'll catch you guys in the next one.